All right, so this is your video for the second half of 3-7. This is 3-7 day 2. We're going to be looking at some more compound inequalities with absolute value. We did 3 examples of the 7 in this lesson yesterday. We're going to do 3 examples of the 7 in this lesson today, and then tomorrow you're going to do the 7th problem in class. At the top of your paper, go ahead and write 3-7 day 2. Go ahead and write 3-7 day 2. Alright, so at the top of my paper, I've written notes 3-7 day 2. I'm going to start with number 4 because we did 1 through 3 yesterday. So I'm going to start with number 4, and number 4 is 3 plus 7 times the absolute value of x is greater than or equal to 38. So go ahead and get that problem written down. 3 plus 7 times the absolute value of x is greater than or equal to 38. So a lot like number 3 yesterday, we look at this and we can see that our absolute value bars are not isolated. So that's going to be our first step. That's the very first thing we have to do before we can do anything else. So we have to get our 3 and our 7 away from the absolute value bars. We know that we kind of reverse the order of operations and we are going to add and subtract before we multiply or divide. So we're going to subtract our 3 on both sides. These cancel. I'm going to bring down my 7, my absolute value of x, my inequality sign, and then 38 minus 3 gives me 35. Now, when a letter and a number are touching, they're being multiplied. When a number is touching absolute value bars or parentheses, it's being multiplied. So I have to divide in order to undo multiplication, and I'm going to divide both sides of my problem by 7. These 7s will cancel, and 35 divided by 7 gives me 5. I'm going to bring down my absolute value of x and my greater than sign. So the absolute value of x is greater than or equal to 5. Now my absolute value bars are isolated, and I can set up my two separate inequalities. So I'm going to drop my absolute value bars. For my first one, I'm going to say x. I'm going to flip my inequality sign, and I'm going to change my 5 from positive to negative. Over here, I'm simply going to drop my absolute value bars, bring my inequality sign down, and bring down my 5 just like it is. And I'm already done solving here. And now I'm ready to set. I have x is less than or equal to negative 5, or, because I know it was a great or problem, or x is greater than or equal to 5. My greater set notation says x such that x is less than or equal to blank, or x is greater than or equal to blank. I'm going to fill in my numbers from least to greatest, negative 5 and positive 5. And now I've solved and I've set, and now I have to graph. Now this graph spans quite a few numbers. I'm going to write in one number above 5, one number below negative 5, and I'm going to show you the 0 in the middle. Okay? I'll even go so far as to say one number on either side of 5. So I have 4, 5, 6, 6, 5, 4. And my 0 in the middle. Now, I look at my inequality sign, I see an extra mark underneath it, so that means I have to make a closed circle, extra mark, make it dark. This is an or set notation, so I know that my or problem is going to be shaded to the outside. If I'm not sure that I'm shading to the outside, I can look here and see my arrows. My arrow points this way, my arrow points that way, and my shading on my number line points this way and that way. So I've solved, I've set, and now I've graphed, and I have to check. Again, with these OR problems, we're going to check 2 times. We go back to the original problem, which was 3 plus 7 times the absolute value of x is greater than or equal to 38. Check. 3 plus 7 times the absolute value of x is greater than or equal to 38. I go back to the original problem both times. I'm going to check with a negative 6 over here and a positive 6 over here. So I'm going to say 3 plus 7 times the absolute value of negative 6 is greater than or equal to 38. 3 plus 7 times the absolute value of 6 is greater than or equal to 38. The order of operations tells me to multiply. Do anything in grouping symbols first. I have my absolute value bars here with my negative 6, which I changed to a positive 6 because I'm bringing it out of the bars. And 7 times 6 is going to give me 7 times 6, plus 3 is going to give me 45. It's greater than or equal to 38. And over here, this becomes a positive 6 because the absolute value of positive 6 is positive 6. And 7 times 6 plus 3 is going to give me 45. It's greater than or equal to 38. So make sure that you have all of that work, the problem, the solve, the set, the graph, and the check written down before you move on. They both check. All right, let's look at problem number 5. It is 4 times the absolute value of x plus 2 is greater than or equal to 12. Get that down. 4 times the absolute value of x plus 2 is greater than or equal to 12. Now, the first thing I have to look at here is whether or not my absolute value bars are isolated on the side of the on one side of the problem, and they are not. There is this 4 over here in front of my absolute value bars, which means that my bars are not by themselves. So in order to get that 4 away, I have to do the opposite of what that 4 is doing. I know that that 4 is touching these absolute value bars, so it's being multiplied by whatever's inside them. In order to undo multiplication, I have to divide. So I'm going to divide both sides of my problem by a positive 4. These 4s will cancel. 12 divided by 4 will give me 3. So now I'm going to bring down my inequality sign, bring down my absolute value bars, and what's inside them? X plus 2 is greater than or equal to 3. This is a great OR problem. So I'm going to set up 2 separate inequalities. I'm going to bring this down, drop my bars, and say x plus 2 is, flip my sign, less than or equal to, change the sign on my number there, negative 3. Over here I'm going to say x plus 2, bring everything down exactly like it is, just without the bars. It's greater than or equal to positive 3. Now I have a 2 over here with my x, so I have to subtract 2 on both sides, which gives me x is less than or equal to negative 5. Subtract 2 here. X is greater than or equal to 1. So if x is less than or equal to negative 5, x is greater than or equal to 1. I have solved. Now I have to set my OR set notation is x such that x is less than, in this case, or equal to blank, or x is greater than or equal to blank. My OR set notation is not going to change for every single OR problem I work. It's going to look exactly like that with the exception of the numbers that I fill in the blanks. I have a negative 5 and a 1. Negative 5 and 1. I fill them in from least to greatest. I have solved, I have set, now I graph. I'm going to go one number below and one number above my negative 5, one number above, and one number below my 1. I can fill in the rest. I've got room here. It's not that big of a number line. Okay? So at my negative 5, I'm going to put an extra mark, make it dark, closed circle. And at my 1, I'm going to put extra mark, make it dark, closed circle. I'm going to look to see which way I'm going to shade this. It is an OR problem. If I look at my inequality signs like arrows, they're telling me that I am shading outward. I know that an OR problem is always going to be shaded outward. I can shade these outward, and that's done. Now, I've solved, I've set, and I've graphed, and I have to check. So I have to come back to the original problem. Now, I kind of manipulated my original problem up there, so don't forget it was actually 4 times the absolute value of x plus 2 is greater than or equal to 12. Okay? This is my check. Check. This is an OR problem. I have to check both shaded regions. I have to check one number in each of my shaded regions. I'm going to check the 2 and the negative 6. So here I'm going to say 4 times the absolute value of negative 6 plus 2 is greater than or equal to 12. 4 times the absolute value of, 2 plus 2 is greater than or equal to 12. So here, I'm going to do what's inside my grouping symbols first. Negative 6 plus 2 gives me negative 4. Greater than or equal to 12. Alright, and then over here I have 2 plus 2, which is 4. Greater than or equal to 12. Now, the absolute value of negative 4 is positive 4. I'm going to bring it out of my absolute value bars and drop them, change them into parentheses. 4 times 4 gives me 16. 16 is greater than or equal to 12. Over here, the absolute value of positive 4 is positive 4. 4 times 4 gives me 16. And 16 is greater than or equal to 12. So this checks and this checks. They are both greater than 12. So make sure that you have the solve, the set, the graph, and the check all written down before you move forward. Alright, go ahead and get down to number 6. Again, this is the last one that we're going to do on this video, and then you're going to do number 7 in class tomorrow. Number 6 says 5 times the absolute value of x minus 3 plus 9. 5 times the absolute value of x minus 3 plus 9 is less than 29. Just like the last two problems that we worked, we can look at this problem and see that our absolute value bars are not initially by themselves. We have to work the order of operations in reverse to get them by themselves. So instead of multiplying or dividing first, we have to add or subtract. So the very first thing we're going to do is subtract 9 from both sides. It's going to give us 5 times the absolute value of x minus 3. These cancel, is less than 29 minus 9 gives us 20. And now we have this 5 over here with our absolute value bars. We know when we have a number touching our absolute value bars, it's being multiplied. In order to undo multiplication, we have to divide. So now we have the absolute value of x minus 3. These cancel, is less than 20 divided by 5 gives us 4. So now our absolute value bars are by themselves, and we're ready to set up two separate problems. We can look at our inequality sign and see that it is a less than. So we're going to say less than problem. So this is going to be an and problem. I'm going to set up my two separate inequalities, and I'm going to say x minus 3 is, flip my sign, greater than negative 4, and x minus 3 is less than 4. So here I just bring it down and drop the bars. Alright. I've not solved yet because my x is not by itself. I have a negative 3 over here with it. I've got to add 3 on both sides. Negative 4 plus 3 gives me negative 1. And over here, 4 plus 3 gives me 7. So now I've solved my x's are by themselves. I have to set. My and set notation never ever changes. It is always going to be blank is less than x is less than blank. I'm going to fill in the blank from least to greatest, negative 1 and 7. Negative 1 is less than x is less than 7. And I'm going to go ahead and graph this on my number line. I'm going to go one number below negative 1, which is negative 2, negative 1, and one number above, which gives me 0. Here I'm going to go a number above 7, one number below 7, 6, 7, and 8. So I have negative 2, negative 1, and 0, and then 6, 7, and 8. I'm going to shade to the inside. I do not have an extra mark, so I'm going to use an open circle at my 1 and my 7, and I know with an and inequality, I'm shading to the inside. If I'm not sure, I look at my X and I see that my X is on the inside. I shade to the inside. Now I'm going to pick a number within my shaded region, and I'm going to check. I'm going to go back to the original problem. For me personally, I like to check with 0 when I can. 0 is in my shaded region here, so I should be able to check with 0. Now this is an AND problem, so I only have to check one time because I only have one shaded region. And back to my original problem, 5 times the absolute value of x minus 3 plus 9 is less than 29. And again, I'm going to choose 0 because it's in my shaded region and I can. Sorry, I'm running out of space here. I'm going to say 5 times 0 minus 3 plus 9 is less than 29. 0 minus 3 gives me negative 3, but it's still inside the absolute value bars. The absolute value of negative 3 is positive 3. Five times positive 3 gives me 15. Sorry, I tried to make a little more space there. Not able to. 15 plus 9 gives me 24. And 24 is less than 29. So that does check. So make sure that you have that solve, set, graph, and check all written down. And this is your last problem for today. So make sure that you bring your notes to class tomorrow. And thank you for watching.